Right, let's cover these 5 topics here, throwing exceptions and so forth. We'll start with throwing exceptions. Here's a program, and we will start out by just asserting false. So we expect this to crash. We'll get into the assert, and it'll crash. We compile, and we run, and it crashes. Fine, but the error we get is division by 0. And the reason is we're crashing by dividing by 0. Now we want to crash because we have a failed assert. But we'd like to crash with a better error message than division by 0. So we're going to learn how to do this instead. We're going to throw new runtime exception inside here, put our whatever exception we want. Let's say failed assertion. And now this compiles, and it runs, and it crashes. But notice that the error is failed assertion, so we can actually specify the nature of the error. This creates a new exception, a new reason for the program to stop its normal execution. And throw means make this actually occur, make this exception occur. So this is a cleaner way of implementing our asserts than dividing by 0. And that's throwing exceptions. So now we want to talk about variable length arrays, okay? And for that, actually, you know what? I want to do that after. I want to do a toString and equals first, and then we'll talk about these. So right here, we have an array, A, 1, 2, 3. Let's get rid of our assert false here. Actually, let's just do it this way. Okay. So we have our array A, and we go ahead and print it. And we've seen this before. We did this last week. Here's our print array. It goes through every element in the array, and it prints it out, putting commas in between elements. Okay, so far so good. You might make it a little prettier, by the way, by doing this. You probably want to start with a left bracket, and we probably want to end with a right bracket. See what that does. A little cleaner down here, see? Now, what you can do is you can import Java util arrays, which is a class in Java, utility class, and check out one of the things we can do. System out print line of arrays, that's the class name, .toString. Now this is not an object, this is this class, but that has its own toString method that you pass in the array, and watch what we get. And we run. Aha! So it pretty much works the same as print array. Well, not the print array, but it's a toString that you then print. So we don't need print array, and we're going to get rid of it. We're going to instead, for now on, use arrays.toString. Nice. So the next thing would be to check if 2 arrays are equal. So let's go ahead and do that. I'll go here and I'll do B. Sure looks like they're equal. Instead of print array and toString, let's go ahead and simply print if A equals B. And I go ahead and compile this, and I run it, and it doesn't. We've talked about this as well. They're not equal because they are actually, they're not the exact same object. They're not aliases of each other. There are 2 completely different arrays allocated here. They happen to be the same length and contain equal values. So it's like we wish we had, instead of print array, we wish we had arrays equal, if you would. It takes an array and another array and checks if they're equal. And 2 array, I'm adapting print array because it's kind of the same idea in a sense. 2 arrays are equal if what? First off, if their lengths are not equal, if A.length is not equal to B.length, then we'll just return false because they're not equal. Otherwise, we'll go through each element in A, and we'll say if, all right, so now we go ahead and compile, and we run, and we find out that they're equal. Awesome. So now we want to go ahead and show you how to do this more conveniently, because as we know, we saw this is about print line arrays toString of A. We saw arrays had this handy dandy way of printing to strings. Well, guess what? Arrays also has a handy dandy way of doing the equivalent of arrays equal, which is called arrays equals AB. And you go ahead and compile, and you run this, and true, which is to say we don't need to write our own at all. That's what our own would look like because the arrays class already has a method for us that does that. That's arrays equal. So there's toString and there's equals. So far so good. Okay, so now what we want to do, let's put that assert false at the end here. So now what we want to do is look at variable length arrays and statically reallocating arrays. Let's do the static reallocation next. So here's the problem with static reallocation. If I said a equals 3, 4, 5, and I try to compile that, it won't compile. Illegal start of expression. But you can actually do this if you do that, still not, but if you do that, aha, and done. So this is called statically allocating an array when you have the values of the array inside the squiggly brackets or squiggly braces. That's statically allocating. And this is statically reallocating, which you can do as long as you say new int brackets. So I'll go ahead and run that. And naturally 3, 4, 5 does not equal 1, 2, 3. And that's static reallocation. Which brings us down now to variable length arrays. Okay, so what if I had, in this case, by the way, let's go ahead and do that and that. Actually, do this. Plus, comma, plus arrays, toString of b, plus, comma, plus arrays equals ab. Do it all in one line and copy, do that again. So then we'll do where they're the same, we'll do it where they're different, we'll compile, we'll run, we'll see that 1, 2, 3, 1, 2, 3 true, 1, 3, 4, 5, 1, 2, 3 false. Excellent. So now what if I had int n is 3, and now I want to create an array of size n. And if I modify n, the size of the array should change. Aha. So for that, I would say a is a new int, and if you put inside this bracket that integer, that means like int of 5 would be of size 5, int of 10 would be of size 10, int of n is of size n, which allows us to have variable size arrays. So now let's go ahead and do this, and we'll go ahead and compile, and we'll run, and we'll see it created an array of size 3 all loaded up with zeros. If I create instead n of 5, and I compile, and I run, I'm getting an array of 5. See, the length of that array is 5, all zeros. And now we know how we can create variable size arrays. And yes, you are actually guaranteed it will be initialized all with zeros, which is pretty handy. I'll turn the assert on as well and run this, so we'll see the crash with the failed assertion. And this is the code that I will post to Piazza, which covers all the topics of this mini lecture.